All right, here we go. So, I mean, question five, or I'm sorry, 4B, it's not really asking for a rigorous math proof or anything. It's literally just wants you to put in words of what's going on. So, this would be my explanation. So, when we talk about a sphere, everybody thinks about like an orange, maybe. And an orange has an outside, it has an inside. When we talk about a sphere, just like when we talk about a circle, it's the collection of points that are the same distance away from a given point. So when we think about the sphere, just think about the skin of a basketball. Just the outer surface is the sphere. The inside has nothing to do with the sphere. So it's just that surface. Now imagine a piece of paper, and the picture is kind of what they're trying to show you here. Imagine a piece of paper that slowly would descend and go through the circle. Imagine it like being absorbed in there. And the outline that sphere, the skin of the basketball, would make on the paper would be a circle. And so that's all they're really asking you to do is explain why the intersections of a plane of sphere is a circle. Interestingly enough, if you were to, and that's through the middle of the sphere, it's got to be through the middle. Interesting enough, if you look at the picture right there, if you were to tilt the plane in an upward direction, you would get a squash circle, an ellipse. So you only get a circle, and this is why it's called through the center, called the great circle. Interestingly enough, if you don't go through the circle, then you make an ellipse, not a circle. All right, so that's 4B, and I gave you can read these words here. That's how I would have done it. The book doesn't actually even give an answer to it. So let's see, 5B. This just requires you to draw some pictures. You can see the answer there, 8 and 22. And here's the explanation. So if you're concentric circles, those are two circles on a plane that share the same center. So there's two circles on a plane that share the same center. So it says they have a radius of 7 and 15. So clearly the small one would have to have a radius of 7, and the larger one would have to have a radius of 15. Now I drew a diameter there, because then the very next sentence talks about the diameter AB. But if the AB is your diameter, there's AB, then half of that diameter would be the radius. So from the center to either A or B, that would be 15. That 15 right there is from the center of the circle outward. Okay, so why are there two possible answers here? Because then it says find two possible answers for AC, but where are AC? So if you look at that diameter, where that diameter AB intersects the smaller circle, are points C and D. But it doesn't tell us where C and D is. C the first one and D the second one, or vice versa. So if I make C the first one and D the second one, well, then that leaves open the possibility that it could be the other way around. So there are your two possibilities. And when you do the math now, I'll do the left one first. Let's see. I got to figure out how far it is between what are the possible values for A to C. So the one there on the left there, it's small. So if 15 is from the center outward, I would have to subtract from 15 that 7 to get to AC, and that would give me the value 8. And on the one on the right there, AC now would be 15. 15 would be A from A to the center, and then I have to add on another 7, so that would be 22. And there's your two possible answers there. I like 5. It's a good question, but it's definitely you need to take your time and read it slowly and carefully to get to that answer. All right, so 12 through 15, it's basically the same idea. You got a circle with radius of 12, and then you got certain angles. And here's 12. So it says 12, you get angle AOB is 90 degrees. So I have the two radii 12, and then it says how long is AB. So AB is a chord AB, and let's see, I made a triangle. In fact, I made an isosceles triangle, and we know that an isosceles triangle, that's right, is a 45, 45, 90. Further, we know that for 45, 45, 90, the hypotenuse is equal to A root 2. And, well, we've got one of the legs is A, and if A is 12, then that means that the hypotenuse is 12 root 2. So that's number 12. All of these either end up being special right triangles or something like that. Some little trick involved. 13 is, well, if you think about it, if it's 180 degrees, then it's a diameter. So therefore, 12 and 12 is 24. Number 14, well, we got a 60-degree angle. If we make a triangle out of that, it's still isosceles, so that means the other angles are equal. If one of the angles is 60, that leaves 120 degrees, but divide that by 2, and that means that they're all 60, so it's equilateral, so that means all the sides are equal. Therefore, AB is 12. And on the last one, number 15, let's see, 120 degrees. Well, I got nothing for that. So here's what I would say. And once you see this number 120, it becomes a bit more apparent. So if you flip this upside down, so we would get a triangle that's 120, and then there's 60 left over. So it'd be 30, 30, 120 would be the triangle. Now I'm going to flip that triangle upside down and cut it in half. And therefore, if you cut 120 in half, we get 60 degrees. So it's a 30, 60, 90, or two 30, 60, 90 triangles. And it looks like the hypotenuse is 12. And we know that on a 30, 60, 90 triangle, the hypotenuse is equal to 2a. So if 12 is equal to 2a, then a is equal to 6. And what are we trying to find? The dotted line, that would be the bottom there. That would be all the way across the bottom. And we know that the long leg of a 30, 60, 90 triangle is a root 3. We just figured out a was 6. So that means that the long leg is 6 root 3. That's half of it. So the other side would also be 6 root 3. That would be the red dotted line. So double 6 root 3 would be 12 root 3. And there you go. There's your explanation.